You are listening to Access for All, designing a web without barriers. Like and subscribe to keep up to date on our latest audiobooks. Access for All, designing a web without barriers. 1. The invisible exclusions. Why web accessibility matters. Imagine a world where the buildings you need to enter, your bank, a grocery store, a doctor's office, often had stairs but no ramps, where the signs were too small to read or the doors too heavy to open. Such a world would be a constant source of frustration, exclusion, and unnecessary barriers for many. For most, these physical obstacles have largely been addressed by inclusive design and building codes. But what about the digital world? Today, our lives are interwoven with the internet. We rely on websites and apps for everything from banking and shopping to education, healthcare, civic participation, and staying connected with loved ones. The web is no longer a luxury. It's an essential utility, a gateway to modern society. Yet, for millions around the globe, this gateway is riddled with invisible barriers that can be as formidable as a flight of stairs or a locked door. These are the barriers of an inaccessible web. This is where web accessibility comes in. At its heart, web accessibility means designing and developing websites, tools, and technologies so that people with disabilities can perceive, understand, navigate, and interact with them. It's about ensuring that everyone, regardless of their abilities, can fully participate in the digital world. Beyond disability, broadening the scope of accessibility. While often associated directly with those living with disabilities, the true power of web accessibility lies in its universal benefit. Think of it like this. Curb cuts on sidewalks were originally designed for wheelchair users. But who else benefits? Parents with strollers, delivery drivers with hand trucks, cyclists, tourists with rolling luggage, and even a child learning to ride a bike. What was designed for a specific need ultimately improved the experience for everyone. This is the essence of universal design in the digital realm. An accessible web benefits a far wider audience than you might initially think. People with permanent disabilities. This is the core focus. Individuals who are blind or have low vision, are deaf or hard of hearing, have motor impairments, limiting their ability to use a mouse or keyboard, or have cognitive disabilities, such as learning disabilities, ADHD, or memory impairments. They rely on assistive technologies like screen readers, screen magnifiers, voice recognition software, or alternative input devices to navigate and understand the web. People with temporary disabilities. Think of someone recovering from a broken arm, making mouse use difficult, or an eye infection that temporarily impairs vision. These temporary limitations often mirror permanent ones. People with situational disabilities. Imagine trying to watch a video on your smartphone in a noisy public place without captions, or struggling to read a website on your laptop in bright sunlight. You might be perfectly able-bodied, but your current situation creates an accessibility barrier. Older adults. As we age, many natural abilities like vision, fine motor control, and even aspects of cognitive function can decline. Accessible design, with its emphasis on clear fonts, high contrast, simple navigation, and straightforward language, directly addresses these needs. New or infrequent internet users. Those less familiar with digital interfaces benefit from consistent layouts, clear instructions, and intuitive navigation. Everyone else. Ultimately, a well-designed, clear, and navigable website is simply a better website for everyone. Good accessibility practices often lead to improved search engine optimization, SEO, faster loading times, clearer content, and overall enhanced usability. The ethical imperative, it's the right thing to do. In an age where access to information, services, and social connection is largely mediated by the internet, digital exclusion equates to real-world exclusion. Denying someone the ability to apply for a job, manage their healthcare, enroll in a course, or connect with friends online isn't just inconvenient. It's a profound infringement on their ability to participate fully in society. For centuries, societies have strived to integrate people of all abilities, from removing physical barriers to advocating for equal opportunities. The digital world is merely the newest frontier in this ongoing journey towards a more inclusive society. Ensuring web accessibility is not merely a technical requirement, it is a fundamental human right. It aligns with our deepest values of fairness, equality, and compassion. Consider Alina, a visually impaired senior, who for years relied on her daughter to help her manage online bill payments and access government forms. When her daughter moved abroad, Alina felt a chilling sense of dependence. She knew the information was there, online, but without accessible design, it was locked away behind an invisible wall of images without descriptions and forms that couldn't be read by her screen reader. Her experience is not unique, it's a daily reality for millions. The compelling business case, more than just compliance. Beyond the moral imperative, there's a powerful and growing business case for web accessibility. Organizations that embrace inclusive design stand to gain significant advantages. Expanded market reach. The global purchasing power of people with disabilities is substantial. Ignoring this population means missing out on millions of potential customers, clients, or users. Making your digital presence accessible opens your doors to this untapped market. Reduced legal risk. Accessibility is increasingly regulated by law across the world. In the United States, for example, the Americans with Disabilities Act, ADA, has been interpreted to apply to websites, leading to a surge in costly lawsuits. Similar laws exist in Europe, Canada, and elsewhere. Proactive accessibility is a far less expensive and stressful approach than reactive litigation. Enhanced brand reputation. In an era of heightened social consciousness, companies and organizations that demonstrate a commitment to inclusivity are viewed more favorably. Accessibility builds trust, demonstrates social responsibility, and distinguishes you as a leader in your field. Innovation and improved user experience. Designing for diverse needs often sparks innovative solutions that benefit everyone. Features like closed captions, originally for the deaf, are now used by millions in noisy environments. Clear navigation and well-structured content, designed for assistive technologies, improve usability for all users, including those on mobile devices or with slow internet connections. Better search engine optimization, SEO. Many web accessibility best practices, such as using meaningful alternative text for images, structured headings, and clear semantic HTML, directly align with what search engines look for when ranking content. An accessible website is often a more discoverable website, a glimpse into the past. While the internet feels relatively new, the concept of accessible technology has roots dating back decades. Early advocates recognized that as information moved onto computers, the same barriers found in the physical world could be replicated in the digital space. Laws like the Americans with Disabilities Act, ADA, enacted in 1990, though not originally written for the internet, set a powerful precedent for non-discrimination against people with disabilities. As the web grew, the need for specific guidelines became clear, leading to the development of the Web Content Accessibility Guidelines, WCAG, by the World Wide Web Consortium, W3C, which we will explore in detail in later chapters. The journey towards a truly inclusive web is ongoing, but the path ahead is clear. This book will serve as your guide, illuminating the principles, practices, and tools necessary to design and build digital experiences that welcome everyone. In the next chapter, we will delve deeper into understanding the diverse experiences of internet users, going beyond conventional notions of disability to grasp the full spectrum of human abilities and needs. It's only by truly understanding our users that we can begin to design a web without barriers. 2. Understanding diverse abilities. Beyond the obvious. To design for everyone, we must first understand everyone. When we talk about people with disabilities, it's crucial to move beyond a singular, monolithic image. The reality is a rich tapestry of diverse experiences, needs, and capabilities. Disabilities are not static labels, but complex interactions between a person's condition and the environment they encounter. An inaccessible website, for instance, creates a disability for someone who might otherwise navigate the world with ease. This chapter aims to broaden our understanding of these diverse abilities and introduce the assistive technologies many people use to interact with the digital world. By truly grasping the varied ways people perceive and interact with information, we can build more empathetic and effective solutions. The spectrum of abilities and how they interact with the web Let's explore some of the major categories of abilities and how they relate to web usage. Visual impairments. This category covers a wide spectrum, from total blindness to various degrees of low vision and color blindness. Blindness. Individuals who are blind cannot rely on visual cues to interact with a website. They depend almost entirely on non-visual means, primarily screen readers. A screen reader is software that converts digital text and interface elements into synthesized speech or braille via a refreshable braille display. For a screen reader user, a website's underlying structure, the order of elements in the code, and the presence of descriptive text for images are paramount. If an image lacks descriptive alt text, it simply doesn't exist for them. Example, imagine trying to use a cooking website with a screen reader. A well-designed site would read out recipe for apple pie, heading 1, then ingredients, heading 2, followed by a list of items. An inaccessible site might just say clickable, or worse, nothing at all for critical elements. Low vision. People with low vision have some usable sight, but it may be limited in acuity, field of vision, or light sensitivity. They often use screen magnifiers that enlarge portions of the screen, or they rely on built-in browser zoom features. They benefit greatly from strong color contrast between text and background, resizable text, and layouts that don't force excessive scrolling. Example, a navigation menu with tiny gray text on a light background might be completely unreadable for someone with low vision, even if they can discern other parts of the page. Color blindness. This is an inability to distinguish certain colors. The most common type is red-green color blindness, but blue-yellow and total color blindness also exist. The main challenge arises when color is the only means of conveying important information, e.g., a green dot means available, red means unavailable, or form error messages highlighted only in red. Example, an online store where out-of-stock items are shown only with a subtle red border might be inaccessible to someone with color blindness, who would perceive no difference from available items. Auditory impairments. This includes individuals who are deaf or hard of hearing. Deafness and hard of hearing. For these users, audio content on a website, videos, podcasts, sound cues, is inaccessible without alternatives. They rely on captions, subtitles, and transcripts. Captions, or closed captions, provide a text representation of all spoken dialogue and important non-speech sounds, e.g., door slams, music playing. Transcripts are full-text versions of audio or video content, often provided separately. Example, a university lecture video without captions excludes deaf students. An important audio prompt confirming a transaction might be missed by someone hard of hearing. Motor mobility impairments. This category encompasses conditions that affect movement, coordination, and dexterity. This can include paralysis, tremors, severe arthritis, or conditions that reduce fine motor control. Reliance on keyboard navigation. Many individuals with motor impairments cannot effectively use a mouse or trackpad for precise movements. They navigate websites exclusively using a keyboard tab key to move between elements, enter /spacebar to activate. For some, even a standard keyboard is too challenging. Alternative input devices. These may include adaptive keyboards, switch devices, a single button or lever that cycles through options, or head-wands mouth sticks for typing. Some use eye-tracking technology or voice recognition software, like Dragon Naturally Speaking, to control their computer and browse the web. Example, if a website's drop-down menus or image carousels are only operable via mouse click and drag, they become completely unusable for a keyboard-only user. Buttons too small to reliably click with precision are also problematic. Cognitive impairments. This is perhaps the broadest and often most misunderstood category, encompassing conditions that affect memory, attention, problem-solving, language, and perception. This includes learning disabilities like dyslexia or ADHD, autism spectrum disorder, and conditions like dementia. Challenges. Users with cognitive impairments may struggle with complex navigation paths or inconsistent layouts, long passages of dense text or overly academic language, distracting animations or pop-ups, time pressure for online tasks, remembering steps in a multi-stage process. Benefits from accessibility. they benefit immensely from clear, simple language, plain language, short sentences, common words, consistent navigation and layout, predictable placement of elements, logical and intuitive flow, a clear path from start to finish, sufficient time limits, opportunities to pause or extend time on tasks, visual cues and feedback, indicating progress or errors clearly, minimizing distractions, avoiding excessive animations or flashing content. Example: a medical form that uses highly technical jargon, jumps between sections, and has a strict countdown timer for submission would be a nightmare for someone with a learning disability or short-term memory challenges. Speech impairments, while less directly tied to consuming web content, speech impairments can affect a user's ability to interact with voice-controlled interfaces or provide spoken input. For instance, someone relying on voice activation for an assistive device might struggle if the website's design requires precise verbal commands that are difficult to articulate. Beyond permanent conditions, the temporary and situational. It's vital to reiterate how these categories overlap with temporary states or situational limitations. Temporary. Someone with a hand injury, temporary motor impairment, needs keyboard navigation. A cataract or eye infection, temporary visual impairment, benefits from high contrast and large text. Situational. Trying to pay a bill on public transport with a patchy internet connection, situational cognitive motor impairment, benefits from simplified forms and clear error messages. Watching a video in a cafe without headphones, situational auditory impairment, relies on captions. These examples underscore a crucial point. Designing for extremes often creates better experiences for the average. When we ensure a website is navigable with only a keyboard, it not only helps a user with a motor impairment, but also the power user who prefers keyboard shortcuts, or someone whose mouse battery just died. Assistive technologies, the user's bridge. To bridge the gap between their abilities and a website's design, people with disabilities often rely on assistive technologies, AT. As designers and developers, we don't necessarily need to be experts in every AT, but we must understand what they do and how our design and code choices enable or hinder their functionality. Screen readers, e.g., JAWS, NVDA, VoiceOver. Software that interprets and reads aloud web content, allowing blind or low vision users to navigate via keyboard commands. They rely heavily on proper semantic HTML, e.g., clear headings, lists, alt text for images. Screen magnifiers, e.g., zoom text. Software that enlarges part or all of the computer screen, making text and images larger and easier to see for users with low vision. Speech recognition software, e.g., Dragon Naturally Speaking, built-in OS tools, allows users to control their computer and dictate text using their voice, essential for many with motor impairments. Alternative input devices. A broad category including trackballs, joysticks, head pointers, mouth sticks, and single switches. These replace or supplement traditional mouse and keyboard input. Braille displays. Hardware devices that translate screen content into tactile braille, used by some blind individuals. Closed captions and transcripts provide text alternatives for audio and video content. Understanding these diverse abilities and the technologies that support them is the first step towards true empathy in design. It shifts our perspective from building generic solutions to appreciating the rich spectrum of human interaction. In the next chapter, we will introduce the foundational principles that guide us in creating web experiences that are truly accessible to everyone. 3. The foundation. Core principles and universal design. Imagine a city planner designing a new public building. They wouldn't just think about how a fully able-bodied person might use it. They'd consider various needs. A parent with a stroller, someone using a wheelchair, a delivery person, or an elderly visitor. They would incorporate ramps alongside stairs, clear signage, automatic doors, and spacious restrooms. This approach is called universal design, the design of products and environments to be usable by all people, to the greatest extent possible, without the need for adaptation or specialized design. Web accessibility is, in essence, universal design applied to the digital realm. Just as a physical building should offer multiple pathways for different visitors, A website should offer multiple ways for information to be perceived and interacted with. To guide this effort, the Web Content Accessibility Guidelines, WCAG, are built upon 4 foundational principles, often remembered by the acronym POUR. These principles are the bedrock of an accessible web, providing a conceptual framework that helps us understand why certain accessibility features are necessary. The POUR principles, your guiding stars. Each of the 4 POUR principles forms a crucial pillar for accessibility. If any one of them is neglected, the website or application becomes inaccessible to some users. P. Perceivable. Meaning, information and user interface components must be presentable to users in ways they can perceive. This means that users must be able to recognize the content and interface elements on a page, regardless of their sensory abilities. If a user can't perceive your content, they simply cannot use your website. Considerations for perceivability, text alternatives for non-text content. Images, charts, graphs, and videos all convey information visually. For those who cannot see them, there must be a text equivalent. For an image, this is its alt text, alternative text, which a screen reader can announce aloud. For video, this might be a descriptive transcript or audio description. Analogy: imagine a critical safety sign that only uses pictures, with no words. A non-English speaker, or someone who struggles with interpreting symbols, would not perceive its meaning. Similarly, an uncaptioned video or an image without alt text won't be perceived by a user who cannot see or hear it. Alternatives for time-based media. Videos and audio content need captions, transcripts, and sometimes audio descriptions to be accessible to people with hearing or visual impairments. Adaptable content. Content should be structured in a way that it can be presented in different forms without losing meaning. For example, a user should be able to resize text without breaking the layout or change colors for better contrast. Distinguishable content. It must be easy for users to differentiate foreground content from the background. This typically refers to color contrast, text against its background, but also the use of color alone to convey meaning, e.g., if a system indicates available items only by showing them in green. If there isn't enough contrast, some users, especially those with low vision or color blindness, simply won't be able to read your text. O. Operable. Meaning, user interface components and navigation must be operable. This principle ensures that users can interact with the website and perform necessary actions. If a user can perceive the content but cannot operate the interface, the website is still inaccessible. Considerations for operability. Keyboard accessibility. All functionality on a website must be available and operable using only a keyboard. Many users, including those with motor impairments, blind users, and power users, rely exclusively on keyboard navigation. This means every button, link, form field, and interactive element needs to be reachable and actionable with the Tab key, Enter, Spacebar, and arrow keys. Analogy: imagine a door that only opens with a highly specific, complex gesture that you can only perform with your right hand. Someone with a sprained wrist, or who only has use of their left hand, wouldn't be able to open it. Sufficient time. Users need enough time to read and interact with content. This means avoiding overly strict time limits on forms or interactive elements, or providing ways to extend them. Users with cognitive disabilities, or those relying on assistive technology, may take longer to complete tasks. Avoiding seizures and physical reactions. Content should not be designed in a way that is known to cause seizures, e.g., flashing content with certain frequencies. Navigable. Users need ways to easily navigate, locate content, and determine their location within the website. This includes consistent navigation menus, clear headings, and logical reading order. U. Understandable. Meaning, information and the operation of user interface must be understandable. This principle emphasizes clarity and predictability. Users must be able to comprehend the information presented and understand how to operate the interface. Considerations for understandability. Readable text content. Text should be easy to read and understand. This involves using clear, concise language, avoiding jargon, and providing definitions for complex terms. Analogy: think of overly complex instructions for assembling furniture or a medical form filled with impenetrable jargon. Even if you can see and touch the words, you don't understand what they mean. Predictable functionality. The way a website behaves should be consistent and predictable. Users should be able to anticipate the outcome of their actions. For example, a button that looks like a button should act like a button. Input assistance. When users interact with forms, they need clear labels, instructions, and helpful error messages. If they make a mistake, the website should explain what went wrong and how to fix it in an understandable way. Consistency. Consistent navigation, design patterns, and terminology across a website reduce cognitive load and improve predictability. R. Robust. Meaning, content must be robust enough that it can be interpreted by a wide variety of user agents, including assistive technologies. This principle is about ensuring long-term compatibility and reliability. Websites should be built using standard technologies in a way that maximizes compatibility with current and future user agents, browsers, and assistive technologies. Considerations for robustness. Maximizing compatibility. Use proper, valid HTML, CSS, and JavaScript. This means using elements for their intended semantic purpose, e.g., using a button element for a button, not just a div. Analogy. Consider a book printed in an obscure, non-standard font. While it might be readable on one specific printing press, other presses or even e-readers might not be able to process it correctly, rendering it incomprehensible. Similarly, if a website uses non-standard coding practices, assistive technologies might not be able to read or interpret its elements. Clear roles, states, and properties. For interactive elements, particularly those built with JavaScript, it's crucial that their role, what they are, state, e.g., pressed, expanded, and properties, e.g., a label are programmatically determined and available to assistive technologies. This is where accessible rich internet applications, ARIA, attributes come into play, helping to convey meaning for complex components that native HTML doesn't fully cover. POUR and universal design. A powerful partnership. The POUR principles are the practical embodiment of universal design for the web. They push us beyond simply meeting a checklist to genuinely thinking about the diverse needs of our audience. For instance, the curb-cut analogy perfectly illustrates how a design solution intended for a specific group, wheelchair users, ultimately benefits many others. Similarly, ensuring adequate color contrast, perceivable, not only helps users with low vision, but also anyone viewing your site on a low-quality monitor or in bright sunlight. Providing keyboard navigation operable assists motor-impaired users, but also power users and people whose mouse batteries just died. Clear, concise language, understandable, benefits users with cognitive disabilities, but also those for whom English is a second language or simply anyone in a hurry. And building with robust, standard code ensures your site works well not just for assistive technologies, but also for new browsers and devices yet to be invented. By integrating these POUR principles into every stage of the design and development process, we move away from retrofitting accessibility as an afterthought, and instead embrace it as an integral part of creating a web that truly lives up to its promise of being open and accessible to all. In the next chapter, we will dive into Web Content Accessibility Guidelines, WCAG, the comprehensive standard that translates these POUR principles into specific, testable criteria. 4. Decoding WCAG. Your map to digital inclusivity. Imagine trying to build a truly accessible structure, a building, a park, a transit system, without any blueprints, standards, or building codes. It would be a chaotic, inconsistent, and ultimately exclusionary mess. The digital world is no different. To ensure a consistent level of accessibility across the vast and ever-growing web, we rely on a globally recognized standard. The Web Content Accessibility Guidelines, WCAG. WCAG, pronounced WCAG, serves as your map to digital inclusivity. It's not just a technical document for developers. It's a living testament to the shared understanding of what constitutes an accessible web. Understanding WCAG, even at a high level, is crucial for anyone involved in building or managing a website, from content creators and designers to project managers and business owners. What is WCAG? WCAG is a set of recommendations published by the World Wide Web Consortium, W3C, the main international standards organization for the World Wide Web. Specifically, WCAG is developed by the Web Accessibility Initiative, WAI. Within the W3C, it's important to understand that WCAG itself is a recommendation, not a law. However, it is the de facto benchmark for web accessibility, and many laws and policies around the world, which we'll discuss in Chapter 8, directly reference WCAG as the basis for legal compliance. The primary goal of WCAG is to provide a single, shared standard for web content accessibility that meets the needs of individuals, organizations, and governments internationally. It offers concrete, testable criteria for making web content accessible to people with a wide range of disabilities. A look at WCAG versions. WCAG has evolved over time to keep pace with web technologies. The most widely adopted and legally referenced version currently is WCAG 2.1, while WCAG 2.0, published in 2008, laid the foundational principles. WCAG 2.1, published in 2018, added new success criteria that specifically address mobile accessibility, low vision, and cognitive disabilities, reflecting advancements in technology and a deeper understanding of user needs. As of this writing, WCAG 2.2 is an upcoming recommendation slated to add even more criteria, and discussions around WCAG 3.0, codenamed Project Silver, are actively underway, aiming for a more flexible, testable, and broader standard to encompass emerging technologies like VR and IoT. While versions evolve, the foundational core principles remain constant, illustrating their timeless relevance. The hierarchical structure of WCAG. To avoid getting lost in the technical weeds, let's understand WCAG's structure. It's organized hierarchically, moving from broad concepts to specific, testable statements. Principles, the why. These are the four core principles we discussed in the previous chapter. Perceivable, operable, understandable, and robust. They are the high-level goals for accessibility. There are only four, and they define the core objectives. Guidelines, the what. Under each principle, there are several guidelines. These are general statements that provide the fundamental objectives for accessibility. There are 13 guidelines in WCAG 2.1, e.g., provide text alternatives for non-text content, make all functionality available from a keyboard, make text readable and understandable. Success criteria, the how. This is where WCAG gets practical. Each guideline has one or more success criteria. These are specific, testable statements that define what must be done to meet the guideline. Think of them as bullet points or checkpoints. They are written in a way that allows them to be objectively tested. You can either pass them or fail them. Each success criterion is numbered for easy reference, e.g., 1.1.1 non-text content, 2.1.1 keyboard, 2.4.4 link purpose, in context. Levels of conformance, the how much. WCAG recognizes that achieving full, comprehensive accessibility can be an enormous undertaking, especially for complex websites. Therefore, it defines 3 levels of conformance, indicating the degree to which a website meets the success criteria. Level A, single A. This is the lowest level of conformance and represents the bare minimum for accessibility. Websites at this level might still be very difficult to use for many individuals with disabilities. It covers fundamental access barriers. Meeting only Level A is often insufficient for legal compliance or good user experience. Level AA, double A. This is the most commonly targeted level for organizations and the one most often referenced in laws and policies worldwide. Achieving Level AA means that major barriers have been addressed, and the content is generally accessible to most people with disabilities. It balances impact with feasibility, providing a good baseline for significant accessibility without being overly restrictive. Level AAA, AAA. This is the highest level of conformance, requiring the most rigorous attention to accessibility. While achieving AAA means providing the maximum level of accessibility, it is often difficult or impossible to satisfy all AAA criteria for all types of content. For example, WCAG itself states that it is not recommended that entire sites be required to conform to AAA level. Usually, specific content or functionality might aim for AAA, but not the entire website. Recommendation: for most organizations, aiming for WCAG 2.1 AA is the recommended and practical goal for robust accessibility and legal compliance. Why WCAG matters for you? Even if you're not a developer meticulously reviewing code, understanding WCAG's structure and purpose provides invaluable context. For project managers, WCAG provides clear performance targets. You can integrate accessibility requirements into project plans, allocate resources, and set testing goals. For designers, WCAG informs choices about color contrast, font sizes, visual hierarchy, and interactive elements. It moves design beyond just aesthetics to functionality for all senses and interactions. For content creators, WCAG guides decisions on clear language, logical heading structures, meaningful link text, and alternative descriptions for images and media. For business owners, WCAG helps mitigate legal risk, expand market reach, and enhance brand reputation. It provides a measurable framework to ensure your digital assets are inclusive. Imagine you have an image on your website that displays a complex chart illustrating quarterly sales growth. Principle: perceivable because the chart is visual content. Guideline: 1.1 text alternatives, because you need to provide a text version of the visual information. Success criterion: 1.1.1 non-text content level A. All non-text content that is presented to the user has a text alternative that serves the equivalent purpose. To meet this success criterion for your chart, you wouldn't just write "chart of sales growth" as the alt text. That's not equivalent. Instead, you provide a concise text summary of the key data or trends in the alt text, e.g., chart: quarterly sales increased steadily from Q1 to Q3, then sharply declined in Q4 due to product recall. For very complex charts, you might also link to a full data table or detailed description. This structured approach, from broad principle to specific, testable criterion, is what makes WCAG so powerful. It demystifies accessibility, providing a clear roadmap for creating inclusive digital experiences. In the following chapters, we will take these abstract principles and criteria and translate them into practical, actionable advice for designing and building accessible websites, moving from theory to implementation. 5. Designing with empathy: visuals, content, and interactions. Design is far more than just making things look pretty. At its core, good design solves problems and facilitates experiences. When we design with empathy, we anticipate the diverse needs of our users and build interfaces that are intuitive and usable for everyone. In this chapter, we translate the abstract core principles and WCAG guidelines into concrete design practices, focusing on the visual aspects, the content we provide, and how users interact with our digital creations. Visual design for perception: perceivable. Effective visual design ensures that information is easily perceived by all users, including those with visual impairments or situational limitations. Color contrast: seeing clearly. One of the most fundamental aspects of perceivability is color contrast. For text to be legible, there needs to be a sufficient difference in luminance, brightness, between the text and its background. WCAG specifies minimum contrast ratios: normal text, at least 4.5:1 ratio between text and background. Large text, 18 pt or larger, or 14 pt bold or larger, at least 3:1 ratio. Non-text elements, e.g. icons, UI components, at least 3:1 ratio. Practical tips: avoid low-contrast combinations. Light gray text on a white background or light pastel colors against each other are notorious for failing contrast checks. Utilize contrast checker tools. There are many free online tools, e.g. WebAIM Contrast Checker, Stark plugin for design software, that allow you to input hex codes and instantly check their contrast ratio against WCAG standards. Don't rely on color alone to convey meaning. While color is a powerful visual cue, it can be problematic for individuals with color blindness or those using monochromatic displays. If color conveys critical information, e.g., green for pass, red for fail, always supplement it with another visual indicator like an icon, an underline, or text. Typography. Crafting readable text. The way text is presented significantly impacts readability for everyone. Font choice. Opt for highly readable fonts, often sans serif fonts for body text. Fonts with overly thin strokes, highly decorative styles, or complex serifs can hinder readability, especially at smaller sizes or for those with low vision. Font size. Ensure a comfortable base font size, typically 16px or larger for body text. More importantly, ensure text is resizable without loss of content or functionality. Users should be able to zoom in on your page, using their browser's zoom function, without the layout breaking or content disappearing. Line height, leading. Adequate spacing between lines of text, typically 1.5 times the font size for body text, improves readability, preventing lines from running into each other. Letter spacing, tracking. Avoid overly condensed or expanded letter spacing, which can make words difficult to distinguish. Paragraph spacing. Use clear spacing between paragraphs instead of just indenting the first line. Text alignment. Left-align text for languages that read left to right. Justified text can create uneven word spacing rivers that make reading difficult. Layout and readability. Clutter-free content. A well-structured layout enhances readability and comprehension for all users, particularly those with cognitive disabilities. Clear visual hierarchy. Use headings, subheadings, and bold text to break up content and guide the user's eye. Related information should be grouped together. Sufficient white space. Don't cram too much information onto a single screen. White space, or negative space, improves comprehension by reducing cognitive load and making elements easier to discern. Responsive design. Ensure your layout adapts gracefully to different screen sizes, mobile, tablet, desktop, without losing content or functionality. This is crucial for users who might need to enlarge text or magnify sections of a page, as responsiveness helps maintain legibility at those scales. Content is king for accessibility, perceivable and understandable. Even the most visually appealing website fails if its content is unclear or inaccessible. Plain language, speak to your audience. Use straightforward, concise language. Avoid jargon, technical terms, or overly complex sentences where simpler alternatives exist. If you must use complex terms, provide clear explanations or definitions. Readability tools like the Hemingway app or readable.com can help assess the reading level of your content. Logical structure. More than just visuals. Headings, H1, H2, etc. are not just for visual styling, they define the structure and hierarchy of your content. Use headings semantically. There should be only one H1 per page, the main title. Subsequent headings should follow a logical, nested order, e.g., H2 for major sections, H3 for subsections of H2. Do not skip heading levels, e.g., jumping from H2 directly to H4. Screen reader users often navigate pages by jumping between headings, so a logical structure is paramount. Use lists for lists. Use unordered ul and ordered all lists for sets of items. They provide semantic meaning that screen readers can convey accurately. Meaningful link text. Context is key. Avoid generic link text like click here, read more, or learn more. These phrases are unhelpful out of context, especially for screen reader users who might tab through a list of links. Be descriptive. Link text should clearly indicate the purpose or destination of the link on its own. Example bad, to learn how to apply, click here. Example good, learn how to apply for our scholarship program. Avoid URLs as link text. Unless it's purposefully meant to be a URL, actual web addresses can be confusing when read aloud by a screen reader. Image alternatives, alt text, the unseen description. Every meaningful image on your website needs descriptive alt text. This text is read aloud by screen readers and displayed if the image fails to load. What makes good alt text? It should be concise, accurately describe the image, and convey its purpose or information within the context of the surrounding content. When to use empty alt text, alt equals. If an image is purely decorative and conveys no information, e.g., a background pattern, a spacer image, use an empty alt attribute. This tells screen readers to skip it, preventing unnecessary distraction. Example, for a photo of a dog playing fetch in a park. Bad, Alt equals dog. Better, Alt equals golden retriever. Good, Alt equals a golden retriever joyfully leaping to catch a frisbee in a sunny park. The best alt text depends on why the image is there. Is it to show dog breeds or a fun activity? Multimedia. Captions, transcripts, and descriptions. Audio and video content must have accessible alternatives. Captions, closed captions. For all videos with speech, provide accurate, synchronized captions. These benefit deaf and hard-of-hearing users, as well as those in noisy environments or who prefer to watch with sound off. Transcripts. Provide a full text transcript for both audio-only content podcasts and video content. This allows users to read at their own pace, search the content, and is invaluable for those who may not be able to process spoken information effectively. Audio descriptions. For videos where important visual information is not conveyed in the audio, e.g., a silent action sequence, a demonstration video, provide an audio description track. This narrates key visual elements for blind or low vision users. Interactive elements and navigation, operable and understandable. How users interact with your website needs to be intuitive and accessible to all input methods. Keyboard navigation, your first test. One of the simplest yet most effective accessibility tests you can perform. Can you use your entire website using only the keyboard? Tab order. Users should be able to navigate through all interactive elements, links, buttons, form fields, in a logical and predictable order using the tab key. The order should match the visual flow of the page. Visible focus indicator. As you tab through the page, there must be a clear, visible indicator around the element that currently has keyboard focus, often an outline by default in browsers. Without this, keyboard users are blind to their location on the page. Operability. All interactive elements must be activatable with the keyboard. Enter for links buttons, spacebar for checkboxes buttons, arrow keys for radio buttons. Select menus. Forms. Guiding user input. Forms are critical interaction points and often key accessibility barriers. Clear labels. Every input field, text box, checkbox, radio button, must have a visible, programmatically associated label. The label tells assistive technologies what the field is for. Simply relying on placeholder text inside the input field is not sufficient. Instructions and examples. Provide clear, concise instructions for completing fields, especially for complex or specific formats, e.g., date formats, password requirements. Error handling. When a user makes an error, clearly identify the error using both color and text, not just color. Explain what the error is and how to fix it. Place error messages near the relevant input field. Ensure error messages are announced to screen reader users, often using ARIA live regions, as we'll discuss in the next chapter. Logical flow. Organize form fields in a logical progression. Group related fields visually and semantically. Consistent navigation. Predictability is king. Consistency greatly aids predictability and usability. Consistent placement. Navigation menus, logos, search bars, and important links should remain in the same location across all pages. Consistent functionality. An icon or component that performs a certain action on one page should perform the same action on another. Designing with empathy means approaching every decision from the perspective of diverse users. It's about remembering Alina and her need for clarity, or the keyboard user meticulously tabbing through your site. By implementing these practices, you're not just adhering to rules. You're crafting a more inclusive, intuitive, and ultimately superior experience for everyone who interacts with your digital presence. In the next chapter, we will look at how the underlying code structure, particularly semantic HTML and ARIA, reinforces these design principles and makes them consumable by assistive technologies. 6 building blocks. Semantic HTML and ARIA for developers, non-code approach. In the previous chapter, we explored how design choices impact accessibility from a user's perspective. Now, we'll delve into the foundational building blocks of a web page, HTML, and a powerful set of attributes called ARIA, and how they communicate our design intentions to assistive technologies. Think of it less as deep programming and more as understanding the language that browsers and screen readers speak. While we won't be writing lines of code, understanding why certain HTML elements are chosen and what ARIA does is crucial for anyone overseeing or collaborating on web development. The power of semantic HTML, speaking clearly to machines. Imagine you're verbally describing a website to someone over the phone. You wouldn't just say, "There are some boxes and text." You'd say, "At the top is the main heading for the page. Below that is a navigation menu with links to different sections. Then there's an article, and within the article, there are subheadings and paragraphs." Semantic HTML is precisely this, using HTML elements according to their intended meaning, rather than solely for their visual appearance. When a browser displays a web page, it applies styles, from CSS, to make the page visually appealing. But underneath, the HTML provides the underlying structure and meaning. Assistive technologies, like screen readers, primarily interpret this semantic structure, not just the visual layout. Here's why semantic HTML is foundational for accessibility. For screen readers use the semantic meaning of HTML elements to announce content clearly to users. They can jump directly to headings, lists, or landmark regions, allowing users to quickly grasp the page's structure and navigate efficiently. For search engines, semantic HTML helps search engines understand the content, often improving search engine optimization, SEO. For future compatibility, properly structured HTML is more robust and likely to work well with new browsers, devices, and assistive technologies as they emerge. Let's look at some key semantic HTML elements and their importance. Headings, H1 to H6. We talked about headings in the design chapter. In HTML, these tags, H1, H2, H3, etc., are not just for making text big and bold. They establish a hierarchical outline of your page's content. The H1 tag should contain the main title of the page, acting as the primary topic. Subsequent heading tags, H2, H3, should be used for major sections and subsections, forming a logical outline. Screen reader users can skim a page by jumping from heading to heading, much like sighted users scan a table of contents or visually skim a page. If you use a div element and merely style it to look like a heading, screen readers won't recognize it as such, making navigation difficult. Lists ul, all, dl. HTML provides specific tags for lists. An unordered list, ul, for bullet points, an ordered list, all, for numbered items, and a description list, dl, for terms and definitions. When a screen reader encounters an ul or all, it announces list with X items, providing crucial context. Using generic div elements with bullet point characters for lists prevents assistive technologies from identifying them as structured lists. Landmark roles, HTML5 structural elements. HTML5 introduced elements like nav, main, aside, footer, header, and section. These elements define distinct regions of a web page, known as landmarks. Nav, for navigation links. Main, for the primary content of the page. Aside, for content tangentially related to the main content, e.g. sidebars. Footer, for copyright info, contact details, related links. Body, the very core of the content. Screen readers allow users to jump directly to these landmark regions, providing a quick way to bypass repetitive content, like headers and footers, and get to the information they care about. Links, V's, buttons, button. These elements have different inherent behaviors and should be used appropriately. A link A is for navigation. It takes you to a new page or a different part of the current page. When a screen reader encounters a link, it announces it as link and often reads the link's text aloud. A button is for performing an action on the current page, like submitting a form, toggling a menu, or adding an item to a cart. Screen readers announce them as button. Using a div that looks like a button but is actually programmed with JavaScript to act like one can be problematic. A screen reader might not recognize it as a button, and it might not be operable with the spacebar, which is the standard keyboard activation key for buttons. ARIA, adding semantic meaning where HTML falls short. While semantic HTML provides a robust structure for static content, modern web applications often feature highly dynamic, interactive components that go beyond the basic capabilities of native HTML. Think of accordions that expand and collapse, tabbed interfaces, complex dialog boxes, modals, or live updating content. Native HTML doesn't always have the built-in semantics to describe these complex interactions to assistive technologies. This is where ARIA comes in. ARIA stands for Accessible Rich Internet Applications. It's a set of special attributes you can add to HTML elements to provide additional semantic meaning and convey the role, state, and properties of user interface elements to assistive technologies. ARIA acts as a bridge, filling the gaps where HTML alone isn't expressive enough. The golden rule of ARIA. The first rule of ARIA is, if you can use a native HTML element or attribute with the desired semantic and behavior, do so. This is often called the no ARIA is better than bad ARIA rule. Native HTML is generally more robust, universally supported, and requires less ongoing maintenance. Only use ARIA when semantic HTML doesn't offer a suitable alternative. Let's look at some key ARIA concepts, simplified. Roles. ARIA roles describe the type or purpose of a user interface element. For example, if you build a custom button using a div, which you generally should avoid, you could add role equals button to tell assistive technologies that this div functions as a button. Other roles include role equals alert for important, urgent messages, role equals dialog for modal windows, or role equals tab for tabbed interfaces. States. ARIA states describe the current condition or status of an element. Area expanded equals true/false, used for elements that can be expanded or collapsed, like accordion headers. Assistive technologies announce whether the section is currently open or closed. Area hidden equals true/false, indicates that an element or its content is not visible or perceivable to any user. Useful for hiding content from screen readers that is visually off-screen. Area disabled equals true/false, indicates that an element is not interactive. Properties. ARIA properties describe attributes or relationships between elements. ARIA label provides a text label for an element when a visible label isn't present or isn't sufficient. For example, a close button using only an X icon might have ARIA label equals close to describe its function. ARIA label EDB, used to connect an element to its label text when the label is already visible elsewhere on the page, but not directly associated with the element. ARIA described B, provides further descriptive text for an element, often used for error messages or instructions when they are visually separate but semantically linked. Live regions, ARIA Live. This is a powerful ARIA feature for dynamic content updates. When parts of a page change without a full page refresh, e.g., a stock ticker, a form submission success message, or a chat window, screen readers typically don't announce these changes automatically. By marking a section of the page as an ARIA Live region, you tell the screen reader to monitor it and announce its content changes. ARIA Live equals polite, announces changes when the user is idle, without interrupting their current task. Good for non-critical updates. ARIA Live equals assertive, announces changes immediately, interrupting the user's current task. Use for critical, urgent information like error messages. JavaScript and dynamic content. Modern web applications are highly interactive, often relying heavily on JavaScript to create rich user experiences. Accessibility challenges arise when developers create custom components from scratch using div elements and JavaScript, without proper semantic HTML and ARIA. Key considerations for JavaScript and dynamic content. Keyboard interactivity. Any custom interactive component, custom dropdowns, sliders, modal dialogues, must be fully navigable and operable with the keyboard. This means ensuring focus can move in and out of the component, and appropriate key presses, enter, space, escape, arrow keys, perform the expected actions. Focus management. When dynamic content appears, e.g., a modal window pops up, keyboard focus should automatically move into that new content. When the content is dismissed, focus should return to the element that triggered it. Without this, screen reader users can get lost on the page. State changes. JavaScript should update ARIA attributes to reflect changes in the UI state. For example, when an accordion section expands, the ARIA expanded attribute on its header should toggle from false to true. This tells assistive technologies what is happening visually. In essence, semantic HTML lays the durable foundation, providing inherent meaning to web content. ARIA then acts as a specialized tool, allowing developers to communicate advanced semantics and dynamic changes to assistive technologies, ensuring that complex web applications are as transparent and usable as simple, static pages. While these concepts might seem technical, their impact is profoundly human. By building with these considerations in mind, we're not just writing code, we're crafting accessible experiences. The next step, once we've built the foundation, is to make sure it actually works for everyone through rigorous testing. 7. Testing for everyone: tools, techniques, and user involvement. You've poured your heart and soul into designing and building an inclusive web experience. You've considered color contrast, used semantic HTML, and even added ARIA where needed. Now comes a crucial question: how do you know if it actually works for everyone? The answer lies in accessibility testing. Just like any other aspect of quality assurance, QA, accessibility testing is not a one-time event. It's an ongoing process that should be integrated throughout the entire product lifecycle. Moreover, no single tool or method can guarantee full accessibility. A truly comprehensive approach combines automated checks, manual audits, and most importantly, testing with real people. The imperfection of automated testing. Automated accessibility tools are a fantastic starting point. They are fast, efficient, and can catch a surprising number of common and easily detectable accessibility issues. What they do: automated tools can quickly scan a web page for things like missing alt text for images, insufficient color contrast ratios, missing form labels or erroneous ARIA attributes, language declarations, simple structural issues. Examples: popular automated tools include browser extensions like AxDevTools or Wave, Web Accessibility Evaluation Tool, and built-in features in browser developer tools like Chrome Lighthouse. Many larger organizations also use enterprise-level scanner tools. Benefits: enables rapid, repeatable checks, catches low-hanging fruit quickly, can be integrated into continuous integration delivery, CI/CD pipelines. Crucial limitation: here's the critical caveat: automated tools can typically only catch about 30 to 50% of accessibility issues. They are excellent at identifying the presence or absence of certain code attributes, but they cannot assess the quality, meaning, or usability of content. Example: an automated tool can tell you if an alt attribute exists for an image. It cannot tell you if the alt text image for a detailed product photo is actually meaningful or helpful. Example: an automated tool can verify that a button is coded as a button. It cannot tell you if that button makes sense in the user flow, or if its functionality becomes confusing when navigated by keyboard. This means automated testing is a necessary first step, but it's never enough on its own. The nuance of manual accessibility checks. Manual testing involves a human reviewing the website with an accessibility mindset, simulating various user experiences. These checks uncover the 50 to 70% of issues that automated tools miss. 1. Keyboard-only navigation, the foundation of operability. This is arguably the most crucial manual test, and often the first step in any robust accessibility audit. How to do it: unplug your mouse, or just commit to not using it. Starting from the top of the page, press the Tab key repeatedly. Do you see a visible focus indicator, an outline around the current element, around every interactive element, links, buttons, form fields? Does the focus move in a logical and predictable order that follows the visual layout of the page? Avoid keyboard traps, where focus gets stuck in a loop. Can you access and activate every interactive element using Enter for links and most buttons, and Spacebar for checkboxes, radio buttons, and some buttons? Can you escape from pop-ups or modal windows using the Escape key? When the pop-up closes, does focus return to where it was before it opened? Can you fully interact with complex components, e.g., drop-down menus, carousels, accordions, using just the keyboard? 2. Screen reader testing, basic exploration. While full screen reader expertise takes time, Anyone can learn to do basic screen reader checks to get a feel for the user experience. Tools: NVDA Non-Visual Desktop Access, free and open-source screen reader for Windows. VoiceOver, built into macOS, CMD plus F5 to activate, deactivate, and iOS. TalkBack, built into Android. What to look for? Is the page title read correctly? Are headings read aloud, and do they follow a logical hierarchy? Can you jump between them? Are images described meaningfully via alt text? Are form fields read with their corresponding labels? Are error messages announced? Is content read in a sensible order? Sometimes visual order doesn't match the underlying code order. Can you navigate by landmarks, e.g., jumping to main nav? Self-correction. Keep in mind that using a screen reader for the first time can be disorienting. Don't assume that if you find it difficult, everyone using a screen reader does. However, it will highlight crucial errors quickly. For expert analysis, professional screen reader users are invaluable. 3. Zoom and magnification testing. Browser zoom. Test your website by zooming in your browser, Ctrl/CMD++. Does the layout break? Does text overlap or disappear? Does content become difficult to scroll? Your site should remain functional and readable at up to 200% zoom without horizontal scrolling. Simulated screen magnifier. While you might not have dedicated screen magnifier software, consider how your layout would look if only a small portion of the screen was visible at a time. This informs decisions about information grouping and minimizing extraneous content. 4. Color, contrast, and sensory checks. Color contrast. Use a color contrast checker tool to manually verify text and background color combinations on critical elements, especially those missed by automated scans. Color blindness simulators. Use browser extensions or online tools to simulate various forms of color blindness. Does information conveyed solely by color become indistinguishable? Motion animation. Review any animations, videos, or flashing content. Does content flash more than 3 times per second, a WCAG warning for seizure risk? Can animations be paused or stopped? Is there a reduced motion preference for users who get motion sickness? The gold standard. User testing with people with disabilities. While automated and manual checks are essential, they are no substitute for user testing with people who have diverse abilities and use assistive technologies regularly. This is where you uncover the real-world usability issues, the frustrations unique to certain experiences, and the unexpected ways your design might fall short. Why it's essential. Authentic insights. No expert check can replicate the experience of navigating a complex website with a screen reader while also processing life's everyday demands. Uncovers unexpected barriers. Users with disabilities have unique coping strategies and different ways of interacting with technology. They will find issues that even the most diligent tester might miss. Validate solutions. It confirms whether your accessibility efforts actually solve real problems and improve the user experience. How to approach it. Recruitment. Collaborating with advocacy groups, universities, or specialized accessibility agencies can help you find diverse participants. Compensation. Always compensate participants for their time and expertise. Environment. Conduct testing in a comfortable, low-stress environment. Focus. Observe and listen. Ask open-ended questions about their experience. Don't just look for bugs, seek to understand their workflow and challenges. Be prepared to learn. Prioritize. You might not be able to test with every type of disability for every feature. Prioritize based on your target audience and the severity of potential impact. Anecdote. A team spent months perfecting an online booking form, passing all automated and internal manual checks. It wasn't until a user who relied on speech recognition software tried it that they realized a critical flaw. Some of the form fields had identical labels, e.g., 2 fields both just number, making it impossible for the speech software to differentiate which field the user wanted to interact with. A simple change to more specific labels, phone number, account number, immediately resolved the barrier, a small fix with enormous impact, only discovered through real user testing. Integrating testing into the workflow. Shift left. Don't leave accessibility testing until the end of the project. Integrate it early and throughout the design and development process. Test small components as they are built, rather than a whole system at once. Regular audits. Conduct regular accessibility audits, e.g., quarterly, annually, even after launch, to catch regressions and ensure new content remains accessible. Feedback loops. Establish clear channels for users to report accessibility issues, e.g., a dedicated email address or clear contact form. Testing for accessibility is about much more than compliance. It's about ensuring that the digital experiences we build are truly usable and enjoyable for as many people as possible. By combining automated efficiencies with human insights, and by valuing the direct input of people with disabilities, we move closer to creating a web that truly serves everyone. In the next chapter, we will examine the growing legal landscape surrounding web accessibility, reinforcing why these efforts are not just good practice, but often a legal mandate. 8. The legal landscape. Compliance, consequences, and opportunities. For many years, web accessibility was largely seen as a nice-to-have, an ethical consideration, or a marketing advantage. That perception has changed dramatically. Today, ensuring your digital presence is accessible isn't just about doing the right thing. It's increasingly a legal imperative with significant consequences for non-compliance. Governments and courts around the world are increasingly recognizing that access to digital information and services is a fundamental civil right. This chapter explores some of the key legal frameworks fueling the accessibility movement, highlights notable cases that have shaped the current environment, and underscores both the risks of inaction and the opportunities that come with proactive compliance. Why legal compliance matters. Beyond the ethical and business benefits we've already discussed, legal compliance offers direct protection and tangible advantages. Risk mitigation. Avoiding costly lawsuits, fines, and protracted legal battles. Level playing field, ensuring that all individuals can access essential services and information, promoting equity. Global harmonization. While specific laws vary, many converge on WCAG as the de facto technical standard, simplifying compliance efforts for global organizations. Key legal frameworks around the world. Many countries have enacted legislation that either directly mandates web accessibility or has been interpreted by courts to cover digital spaces. Here are some of the most influential. United States, the Americans with Disabilities Act, ADA, and Section 508. The Americans with Disabilities Act, ADA, enacted in 1990, is a landmark civil rights law that prohibits discrimination against individuals with disabilities. While originally designed for physical spaces, like buildings and transportation, its title III, which covers places of public accommodation, has been widely interpreted by courts to extend to websites and mobile applications of businesses and organizations that offer goods or services to the public. Key point: the ADA itself doesn't explicitly name WCAG or outline specific technical requirements for websites. However, through a series of legal cases and settlements, WCAG 2.0 AA or 2.1 AA has become the widely accepted and legally advisable de facto standard for ADA compliance. Who it applies to: businesses and nonprofit organizations that serve the public, including e-commerce sites, healthcare providers, educational institutions, restaurants, and many others. Section 508 of the Rehabilitation Act is another crucial piece of U.S. legislation. It requires federal agencies and organizations receiving federal funding to make their information and communication technology, ICT, including websites, software, and electronic documents, accessible to people with disabilities. Key point: unlike the ADA, Section 508 does explicitly reference technical standards, aligning most recently with WCAG 2.0 AA. Who it applies to: federal agencies and contractors or entities that receive federal funds or conduct business with the federal government. Canada, Accessibility for Ontarians with Disabilities Act, AODA, and others. Canada has a patchwork of federal and provincial accessibility laws. The Accessibility for Ontarians with Disabilities Act, AODA, is particularly significant, requiring organizations in Ontario, including small businesses, large organizations, and the public sector, to meet specific accessibility standards for information and communications, including websites. Key point: AODA explicitly references WCAG 2.0 AA as the technical standard for Internet websites and web content. Who it applies to: public sector organizations and private sector organizations of a certain size in Ontario. European Union, EU, the EU Web Accessibility Directive and the European Accessibility Act. The EU Web Accessibility Directive, EU 2016-2102, mandates that public sector entities across EU member states make their websites and mobile apps accessible. Key point: this directive harmonizes accessibility across the EU public sector, requiring adherence to WCAG 2.1 AA technical requirements. Who it applies to: member states' central, regional, and local public sector bodies. A newer and broader piece of legislation, the European Accessibility Act, Directive, EU 2019-882, goes further. While it primarily focuses on products and services, such as banking services, e-books, e-commerce, and operating systems, its scope includes aspects that intersect heavily with web accessibility. Its aim is to set common accessibility requirements for specific products and services sold or used in the EU. Key point: this act is anticipated to increase the pressure on private sector companies doing business in the EU to ensure their digital offerings are accessible. Who it applies to: a wide range of businesses and industries whose products and services are covered by the Act within the EU market. United Kingdom, the Equality Act 2010. Similarly to the ADA in the US, the Equality Act 2010 in the UK prohibits discrimination against individuals with protected characteristics, including disability. While it doesn't specifically name websites, courts have interpreted its provisions to require digital services to be accessible as a reasonable adjustment to avoid discrimination. As such, UK organizations are also increasingly adopting WCAG standards. Notable legal cases and their impact. High-profile lawsuits have played a pivotal role in shaping the legal landscape, demonstrating that inaccessible websites carry real financial and reputational risks. Target Corporation, U.S., National Federation of the Blind v. Target, 2006-2008. This was a landmark case. The National Federation of the Blind, NFB, sued Target, alleging that its website was inaccessible to blind customers, violating the ADA. Target settled, agreeing to pay millions of dollars and to make its website fully accessible. This case set a precedent, affirming that the ADA applied to websites. Netflix, U.S., National Association of the Deaf v. Netflix, 2012. The NAD sued Netflix over the lack of closed captions for its Watch Instantly streaming content. The settlement required Netflix to provide captions for 100% of its streaming content within 2 years. This case solidified the legal requirement for captions under the ADA. Domino's Pizza, U.S., Robles v. Domino's Pizza LLC, 2019 Supreme Court. Guillermo Robles, a blind patron, sued Domino's, claiming their website and mobile app were inaccessible. Domino's argued that their website, providing access to their physical restaurants, wasn't covered by the ADA. The U.S. Supreme Court declined to hear Domino's appeal, effectively letting a lower court's ruling stand that the ADA does apply to mobile apps and websites that facilitate access to a physical place of public accommodation. This case reinforced the legal application of the ADA to digital platforms, even for companies with physical presences. These cases, and thousands more filed in recent years against businesses of all sizes, send a clear message. Accessibility is no longer optional. Consequences of noncompliance, risks you can't afford. Failing to address web accessibility carries significant risks, litigation and settlements, the most visible consequence. Lawsuits can be lengthy, costly, and result in substantial settlements or damages. Legal fees. Even if a company wins a lawsuit, the legal fees for defense can be exorbitant. Fines and penalties. Government agencies can impose fines for noncompliance with specific accessibility regulations. Reputational damage. News of accessibility lawsuits or inaccessibility can severely harm a company's public image, alienate customers, and reduce brand loyalty. No organization wants to be seen as uncaring or discriminatory. Exclusion from government contracts. For companies seeking federal contracts in the US or public sector contracts in the EU and Canada, demonstrating WCAG compliance is often a precondition. Opportunities of proactive compliance, investing in your future. Instead of viewing accessibility as merely a compliance burden, smart organizations recognize it as a strategic opportunity. Expanded customer base. Opening your digital doors to millions of users with disabilities and their families expands your market reach significantly. Enhanced brand image and loyalty. Demonstrating a commitment to inclusivity builds a positive brand image, fosters trust, and cultivates customer loyalty. Consumers increasingly prefer to support businesses that align with their values. Reduced development costs in the long run. Designing and developing with accessibility in mind from the beginning, known as shifting left, is always more cost-effective than attempting to fix accessibility issues later, which often requires significant reengineering. Innovation. Designing for constraints often sparks creativity and leads to better products and services for all users. Competitive advantage. In crowded markets, an accessible website can differentiate you from competitors, attracting a broader user base and demonstrating leadership. The legal landscape has firmly established web accessibility as a fundamental requirement for operating in the digital age. By proactively embracing WCAG standards and building accessibility into the fabric of your digital presence, you not only mitigate significant risks, but also unlock substantial opportunities for growth, innovation, and positive societal impact. In the next chapter, we will discuss how to shift from tactical compliance to building a sustained culture of accessibility within your organization. 9. Fostering a culture of accessibility. From teams to organizations, we've explored the why and the how-to of web accessibility. From its ethical imperative and business benefits to the detailed principles of POUR, WCAG guidelines, and practical design and development techniques. However, all this knowledge becomes ineffective if accessibility is treated as a one-off project, a checklist item, or solely the responsibility of a single person or department. To truly embed accessibility into your digital DNA, it must become a fundamental aspect of your organizational culture. Building a culture of accessibility means making it everyone's responsibility. It's about moving from reactive compliance to proactive, integrated design and development. It's about seeing accessibility not as a burden, but as an inherent quality of excellent digital products, a continuous journey of improvement. Accessibility is everyone's responsibility. Historically, accessibility was sometimes bolted on at the end of a project, often handled by a single developer or an outsourced consultant. This approach is ineffective and costly. True accessibility is interwoven into every role and every stage of the product lifecycle. Leadership sets the vision, allocates resources, champions the cause. Without leadership buy-in, accessibility initiatives often falter. Product owners, managers define accessibility requirements from the outset, integrate them into user stories and acceptance criteria, and ensure accessibility is prioritized alongside other features. Designers, UX/UI, apply accessible design principles, ensure proper color contrast, legible typography, logical visual hierarchy, and intuitive user flows. They design interactive elements that are inherently accessible. Content strategists, writers, craft clear, concise, plain language content. Ensure proper heading structure, meaningful link text, and provide quality alternative text for images and transcripts for media. Developers, front-end, back-end, write semantic HTML, correctly implement ARIA where needed, ensure keyboard navigability, and handle dynamic content and focus management. Quality assurance, QA testers, conduct automated, manual, and user accessibility testing throughout the development process, not just at the end. Marketing communications, ensure marketing materials, social media content, and email campaigns are accessible. Integrating accessibility into the product lifecycle. The most efficient way to build accessibility is to embed it into existing workflows, not create a separate, siloed process. Discovery and planning phase. Define accessibility goals. What WCAG conformance level do you aim for? What are your key user needs? Include accessibility in requirements. Add accessibility criteria to user stories and functional specifications. For example, as a user, I can submit the form using only a keyboard. Budgeting, allocate dedicated budget for accessibility training, tools, expert consultation, and user testing. Design phase, design system. Build an accessible design system with predefined accessible components, buttons, forms, navigation that meet WCAG standards. This ensures consistency and efficiency. Accessibility reviews. Conduct formal or informal accessibility reviews of wireframes, prototypes, and mockups. Tools like Stark or Axure can aid designers in checking contrast and simulating experiences. Development phase, coding standards. Establish and enforce accessible coding standards, e.g., preference for semantic HTML, proper ARIA usage. Code reviews. Incorporate accessibility as a key part of code reviews. Ask, is this component keyboard operable? Does it convey its purpose to a screen reader? Quality assurance, QA phase. Automated testing. Integrate automated accessibility tools into your continuous integration, CI, pipeline to catch regressions early. Manual testing. Crucially, implement manual testing, especially keyboard navigability and basic screen reader checks. User testing. Conduct regular user testing sessions with individuals with diverse abilities. Launch and maintenance. Ongoing monitoring. Continuously monitor your digital properties for accessibility issues. Automated tools can provide regular reports. Feedback mechanism. Provide a clear, visible way for users to report accessibility issues, e.g., an accessibility statement with contact information. Regression testing. Ensure that new updates or features don't inadvertently introduce new accessibility barriers. Building awareness and training. Knowledge is power. A sustained culture of accessibility requires ongoing education and awareness across the organization. Targeted training. Provide role-specific training sessions. A content writer needs different accessibility knowledge than a front-end developer. Accessibility champions. Identify and empower passionate individuals within each team to act as accessibility advocates. They can be a valuable resource for their colleagues and help spread best practices. Internal resources. Create an easily accessible knowledge base with guidelines, checklists, helpful links, and best practices. Accessibility statement. Publish a public accessibility statement outlining your commitment, your conformance level, e.g., WCAG 2.1 AA, the efforts you've made, and how users can provide feedback or get help. This transparency builds trust. Leadership buy-in, the ultimate enabler. While accessibility is everyone's responsibility, it must be championed from the top. Senior leadership's commitment is crucial for success. Strategic vision. Leaders must articulate why accessibility is a core business value, aligning it with company mission, diversity and inclusion goals, and legal obligations. Resource allocation. Leaders must provide the necessary financial and human resources for training, tools, expert consultation, and dedicated time for accessibility work. Accountability. Establish metrics and hold teams accountable for meeting accessibility goals. Anecdote. One major e-commerce company struggled with fragmented accessibility efforts. Department A built accessible payment flows, but Department B launched inaccessible product pages. It wasn't until the CEO attended a workshop delivered by a blind user who demonstrated the profound difficulty of navigating their site that a top-down mandate was issued. The CEO not only allocated a significant budget, but also made accessibility a key performance indicator for department heads. This executive sponsorship transformed their approach, leading to a centralized accessibility team, mandatory training, and a dramatic improvement in user experience across their platforms. Procurement, ensuring third-party accessibility. In today's interconnected digital ecosystem, organizations often rely on third-party vendors for tools, software, widgets, and services, e.g., analytics platforms, CRM systems, video players, content management systems. If these third-party components are inaccessible, they can compromise the accessibility of your entire platform. Make accessibility a requirement. Include accessibility clauses in vendor contracts. Ask vendors for their voluntary product accessibility templates, VPATS, or other accessibility conformance reports. Test third-party integrations. Don't just trust vendor claims. Test integrated components to ensure they work seamlessly with your accessible digital properties. The long game, continuous improvement. The web is constantly evolving, as are user needs and assistive technologies. There will always be new challenges and new opportunities. Fostering a culture of accessibility means recognizing that it's a marathon, not a sprint. It's about a continuous commitment to learning, adapting, and striving for better, more inclusive experiences. By embedding accessibility into every facet of your organization, from strategic planning to daily execution, you create a truly inclusive digital environment. This not only mitigates legal risks and expands your market, but it also cultivates a more innovative, empathetic, and socially responsible organization. And as we look to the future, this commitment will become even more vital as emerging technologies present both new challenges and incredible opportunities for inclusion. 10. The evolving web. Future trends in inclusive design. We've journeyed from the fundamental reasons for web accessibility to the concrete steps of designing, developing, testing, and integrating it into an organizational culture. Now, as our final chapter, let's look ahead. The web is a dynamic, ever-changing landscape. New technologies emerge, user behaviors shift, and our understanding of inclusive design deepens. What does the future hold for web accessibility, and how can we prepare for it? The overarching theme for the future of inclusive design is that it will become less about fixing existing barriers and more about designing for flexibility and personalization from the ground up, embracing the diverse ways people interact with technology. Artificial intelligence, AI in accessibility. AI is poised to be a powerful, double-edged sword in the accessibility space. Opportunities, automated content description. AI can generate alt text for images, captions for videos, and even audio descriptions, often much faster and more cost-effectively than manual processes. Tools like Google Cloud Vision AI can describe visual content. Personalized experiences. AI could dynamically adapt user interfaces based on individual preferences and needs, learning from a user's interactions to offer optimal contrast, font sizes, or input methods. Intelligent assistive technologies. AI could make screen readers, voice assistants, and other ATs even more intuitive and powerful, better understanding user intent and context. Accessibility auditing. More sophisticated AI-powered tools could go beyond simple syntax checks to analyze usability patterns and context, catching a higher percentage of accessibility issues. Challenges, bias and accuracy. AI models are only as good as the data they're trained on. If trained on biased data, they can perpetuate stereotypes or misinterpret content, leading to inaccurate or even offensive descriptions. Human oversight will remain crucial. Over-reliance. Blind reliance on AI for accessibility risks good enough solutions that fail to capture nuance, empathy, or context, ultimately providing a suboptimal experience. Accessibility of AI itself. The interfaces and outputs of AI systems must themselves be accessible. How do you ensure a chatbot is intelligible to a screen reader user? How do you ensure AI-generated content follows WCAG? Voice user interfaces, VUIs, and conversational AI. The rise of voice assistants like Alexa, Siri, and Google Assistant, as well as AI-powered chatbots, represents a significant shift in how we interact with technology. Opportunities, alternative input. For individuals with significant motor impairments, voice control can be a transformative way to interact with computers and the web. Natural language interaction. Conversational interfaces can simplify complex tasks, making them more accessible for users with cognitive disabilities or those who struggle with traditional visual interfaces. Screenless interaction. VUIs allow for interaction without a screen, opening up possibilities for tasks that don't require visual feedback. Challenges. Clarity and prompts. Designing clear, unambiguous prompts and responses in conversational interfaces is vital. Understanding diverse speech. Voice recognition needs to be robust enough to handle diverse accents, speech impediments, and language variations. Non-visual cues. When there's no visual interface, how does the system convey confirmation, errors, or options without relying on cited interaction. Privacy. Voice commands often involve personal data, raising privacy concerns. Virtual reality, VR/augmented reality, AR, and immersive experiences. As we move toward more immersive digital environments, accessibility will become even more complex, but also more critical. Opportunities. Sensory experiences. VR/AR could create powerful sensory experiences for learning or therapy, potentially providing new ways to engage. Simulations. Allowing people with disabilities to safely practice navigating various environments. Challenges. Motion sickness and sensory overload. Many users experience discomfort, dizziness, or even seizures from immersive graphics, rapid movements, or intense soundscapes. Physical navigation. How do users with motor impairments navigate 3D spaces? Input methods. Adapting controls for diverse input methods beyond hand controllers. Content accessibility. How do you provide alt text for a virtual object? How do you caption spatial audio? Current WCAG guidelines don't directly address these dimensions, and new standards are emerging. Personalization and user preferences. The future of accessibility will move beyond a one-size-fits-all approach to allow for greater user customization. User preferences. Browsers, operating systems, and websites are increasingly allowing users to set global preferences, e.g., preferred text size, high contrast mode, reduced motion, dark mode. Websites that respect these preferences will offer a more tailored and accessible experience. Adaptive interfaces. Websites could dynamically adjust their presentation based on detected user settings or even past user behavior, offering personalized accessibility options. The continual evolution of WCAG and standards. The W3CS work on WCAG is ongoing. WCAG 3.0, Project Silver, aims to be more flexible, outcome-focused, and easier to understand for a broader audience. It plans to incorporate new testing methods, including user experience evaluations, and address emerging technologies. This evolution signals a shift towards a more holistic view of digital inclusion. The role of advocacy and community. No matter how advanced technology becomes, the driving force behind accessibility will always be human advocacy and community. Disability rights organizations, user groups, and passionate individuals continue to play a vital role in raising awareness, performing research, and holding organizations accountable. Their lived experiences are the ultimate source of truth for effective inclusive design. A concluding call to action. The journey towards a truly accessible web is an ongoing one. It's a journey propelled by legal necessity, ethical responsibility, and the immense potential for innovation. It's about remembering Alina trying to pay her bills and the blind user navigating a complex form. It's about embracing universal design principles that benefit everyone. As you step forward, remember these key takeaways. Empathy is your North Star. Design for real people with diverse abilities and situational contexts. Accessibility is not an afterthought. Integrate it into every stage and every role of your digital product lifecycle. Test, test, test. Leverage automated tools, perform manual checks, and most importantly, engage with real users. Stay informed, the digital landscape changes. Stay updated on WCAG updates, emerging technologies, and best practices. Be an advocate, champion accessibility within your organization and beyond. Your efforts contribute to a more inclusive digital world. The web has the unparalleled power to connect, empower, and inform. When we design it with accessibility at its core, we unlock that power for everyone, building a truly universal experience. Let's commit to designing a web without barriers, for today and for the future.